Thank you for taking the time to learn more about workplace safety. Over the next couple of minutes, I'd like to fill you in on what's coming up in this online course on fundamentals of fall protection. Overall, this course will take about 2 hours to complete. It's divided into 6 modules, each covering a different aspect of fall protection. This course is designed to ensure you have a solid foundation to build or manage your own fall protection program, or begin using it as a worker. It is not designed to be a replacement for your company's fall protection training, as it does not meet all the requirements for employee training. However, we recommend that you use this course as a supplement to enhance certain aspects of your training program. For your convenience, each of the 30 videos in this course are available for download on our website and on our YouTube channel. We interviewed some of the leading experts and knowledgeable users of fall protection to provide an opportunity to present this information to you. We cover the basics of who, what, where, when, why, and how. Fundamentals is the first course in the Fall Protection Suite. Once you've completed this course, there are 4 industry-specific courses to choose from. These are Fall Protection for Roofing, Fall Protection in Construction, Walking Working Surfaces, and Ladder Safety. At the end of this course, you'll be asked to provide your name, email address, and CCB number if that's applicable. We'll use this information to generate a certificate of completion and ensure that you get proper continuing education credits. If you have any questions along the way, feel free to give us a call at 503-947-7443 or email us at ed.web@oregon.gov. Let's get started.
I woke up that morning, said goodbye to Laurel, opened up our son's room and checked in on our 2-year-old. He was sound asleep, and had a cup of coffee. So I jumped in the truck and drove to Everett, Washington. The weather was bad, and I was the first one there. We got our rigging all set up and went to the supervisors, and they went up and checked all our safety lines and gave us the okay to start power washing. Towards the end of the day, we got to a location of 30 feet. So it was my idea to say, hey, let's pick it up and set it on the inside of the handrail. I was tied off at the time. I unhooked my lanyard, hooked it back to myself, and my coworker put his hands up and said no. So I climbed up on the handrail, and then something odd happened. Something's not right. I was thrown back about 10 feet and down 30 feet. The hard hat came off, safety glasses came off, and I'm still almost in a panic. And at that point, I was completely lost. I didn't know which way was up. And I landed on the back of my head first. So I tried to take a little breath, and I couldn't breathe. And then the pain went away. It got warm. It was peaceful. I don't know what you call that transition, but I was okay with it. I was okay. And then while I was in that transition, I felt somebody touch me, and a tiny, tiny breath finally came. And it was my coworker who had run down the 3 flights of stairs. And then he went down and got help.
It was Friday night, and it was about 5 o'clock, about time to go home. And my supervisor came to me and she said, "You have a phone call." Nobody wants to get that phone call. And nobody wants to make that phone call. All they could tell me was that my husband had been in a serious accident and that I had to get to the hospital right away. So, between my tears and the rain on the windshield, I don't know really how I made it. I don't know how long it took. I just kept thinking, how would I tell our son his daddy's not coming home? It's not worth it. You don't understand how many people are affected and how deeply they're affected when you have an accident. Just being unsafe is just selfish. And it's not worth it.
Fall hazards are present at almost every workplace. Any walking working surface can be a potential fall hazard.
And what is the approximate distance from the ground?
Well, the first, second, third floor is 16 stories, 48, 58, 68, 78, about 80 foot.
How many people are hurt?
I have no idea. We're all trying to get off the deck right now.
A construction worker is dead after falling off of a ladder while building a home.
Some people get lucky, land on their feet, or they bounce because it's a short fall. But then there's other longer falls where you go and you fall and you stick your arms out, you tear your rotator cuffs, you break your pelvises. Other thing like that.
This is the second death in 5 days here in Canton. Last Wednesday, a worker died after falling off a roof on a building on Draper Lane.
Everybody makes mistakes sooner or later. These guys work over 2,000 hours a year. If you do that for 20 years, at some point you are going to make a mistake. I've seen plenty of people make those mistakes, fall under their harnesses or just plain fall.
He's inside the building. He fell through the roof.
He fell through the roof? Okay.
Yes, correct, onto the concrete.
I would say at 20 feet, going that fast, you land on the concrete and you walk away from it, you're a very lucky individual. You're probably going to be crippled for the rest of your life or you're going to be dead, especially if you take a head impact.
There's blood all over the place. Is he breathing?
Where's the blood coming from?
Yes, he's breathing.
Okay.
It looks like blood's coming from his head. He's barely breathing.
Have you ever heard the old cliche, it's not the fall that kills you? What is it? The sudden stop at the end. Do you think they're lying? They're not lying. Because I tell you what, you're falling, bam, you hit. What stops? Your body. What doesn't stop? Your organs. So they crash into the back of your rib cage and they blow up. You can't take the force. Do you know what it takes to break a man's collarbone? 8 pounds.
A roofer fell off this 3-story roof to the pavement below where he was pronounced dead.
We oftentimes fail to recognize the harm done to a family, surviving spouse, children, moms and dads, grandparents, and the futures that those individuals held.
The victim's colleagues and family are devastated by this workplace accident.
He was only 24?
25. If they allow somebody to get up there and work without fall protection and they fall, that's one of your family members that just got hurt. And I don't think they think about it in that fashion until afterwards when it's too late.
Moving on to other news now, a construction worker slipped and fell 30 feet into a water tank.
Anybody that works at Heights, whether they're a first day on the job or they're the president of the company, the rules apply, period, because gravity does not discriminate.
Fatal falls to a lower level in private construction increased from 255 in 2011 to 370 in 2016, a 45% increase. In all other industries combined, the increase was 10%. Over the 6-year period, more than half the fatal falls to a lower level occurred in private construction.
What is fall protection? Ask 10 different people what fall protection means, and you're likely to get 10 different answers. For many in the construction industry, equipment that comes to mind are things like guardrails, personal fall protection systems like fall arrest, or perhaps safety nets. But fall protection is more than equipment. Fall protection is anything you do to eliminate and prevent falls, or make sure that workers who do fall are not injured. Fall protection is not just a system. It's how you look at a job or task. Beyond that, you could even say it's a commitment. There were companies using fall protection in the form of safety nets at work sites before OSHA was established. Why would they do that? The reason is because human life was valuable to them. Coming home to their families at the end of each day meant something to them, and it should to you too. Whether you are an employer or an employee, we all play a part in workplace safety. At a basic level, here's what a fall protection system is comprised of. Identifying and evaluating fall hazards. Eliminating fall hazards before considering other options like fall arrest. Implementing appropriate systems for each situation. Inspecting and maintaining those systems. Training workers appropriately, and of course, understanding Oregon OSHA's fall protection rules. We'll go into more detail about what these components mean to you over the next few modules.
History as far as fall protection in construction, borders on get the job done, and very few protections provided by the employer in terms of training, very little legislation in terms of codes and standards by states or at the federal level, and if you needed a job, you did what you were required to do to get the job done without emphasis on personal safety whatsoever. The rules came about because there was a need to stop the slaughter of construction workers, and we were. Our values changed in the 60s, and that caused an increase in rules and regulations. In locating to Oregon in the mid-70s, fall protection was a very hot issue nationally and within the state, and was approached to help develop some of the early rules and regulations for initially federal OSHA and then the states of Oregon and Washington as well. As we began to trace construction accidents, falls from elevation always ranked in the top 3 nationally, and early focus was on reducing the number of incidents, accidents, and fatalities within that industry. The time frame that I grew up in and developed in the industry perhaps started in the mid-60s when we began taking an interest in injuries and accidents in the construction industry. Rules and regulations and OSHA came about early 70s. Oregon as a state was kind of in the midst of adopting the codes and standards that were there, and those began to develop from the federal standards once they were published and became mandatory to the states. Fall protection has come a long ways from a body belt and a 6-foot rope lanyard. What led to it was that we could no longer take the damage to the human frame with the equipment we thought was fall protection equipment. It wasn't misnamed, perhaps, and more importantly, frequently misused. So we needed better tools, needed a way to reduce the impact, needed to increase the survivor of the persons wearing the equipment that experienced a fall, and needed to train them so that they understood the hazards that their person was subjected to, also the requirements of the codes and standards that were coming into the industry around the same time. The question here is it easier before the 70s or after the 70s concerning rules, regulations, and equipment? There is no excuse today not to use it. Being qualified as an expert witness in my field and being on more than one trial, with numerous accidents investigated, I will tell you there is no excuse.
And my injuries that day was I cracked my head, broke the back in 3 places, severed the spinal cord, broke the clavicles, broke the ribs, and chipped a tooth. It's been almost 23 years, and I went in January 3rd to get my shoulder looked at, and I had had 7 previous surgeries on my left shoulder, and they told me they can't fix it, they can replace it. So I thought, okay, so I went in for a full shoulder replacement. Most people in wheelchairs don't have this done. Within 2 weeks after the surgery, it got infected. They fixed the infection in February, then it came back. So February 9th, I had another surgery where they went in and cleaned out the shoulder for the infection. And then I've been on, ever since, antibiotics, PICC line IV, where I have to inject myself every 8 hours with an IV. It's been 22 years, and I'm still dealing with this. It's not going to go away. And now, hopefully, in the next month, I've been functioning without a left shoulder for approximately a month now. It's a tough one, and but it's not going to beat me. But it's very difficult right now. Laurel has to pick me up to get me in bed. I have a hospital bed in the living room. I've been in for 9 months now. This does not go away. It doesn't. I will die in a wheelchair. This is how it's going to end for me. And it's not worth it. Think of your kids. Put a picture of them in your hard hat, on your excavator, something to remind you why you're at work.
Wasn't able to teach our son how to ride a bicycle. He tried and tried and tried, and he kept knocking him over. And our neighbor had to come over and teach him how to ride a bicycle, without the training wheels. This is something you don't think about. All the sports that Spence was in, and Russ couldn't really participate. I mean, he could be a team dad, but he really couldn't, practice with them and stuff. And he was a really great runner in junior high school, and he actually did a couple marathons, and Spence got the gene, and he was a runner, but they couldn't do it together. By that time, Russ's shoulders were shot already, so just things like that. He couldn't take him, used to go bird hunting a lot over in eastern Washington, couldn't take him to do that. Steelhead holes, pretty much inaccessible. All kinds of things that he used to do, and wanted to do with our son, he wasn't able to.
This gets to you after a while. It's lonely, being in bed by myself all day. I have caregivers come in, have to help me get dressed, get me out of the hospital bed. It's embarrassing, frustrating. You need to let these people know what I'm saying is it's not worth it. Our son Spencer asked me when he was about 7, he goes, "What do you do at these meetings when you talk to the people?" And I told Spencer, I just tell him the story about me falling, whose fault it was. And if they don't listen to me, I tell them to think of their family. And he goes, why didn't you think of me? Just hugged him and said sorry. That's all I could come up with.
The aftermath of a bad fall, it can be really traumatic. If you look at it in terms of an employer or a business, I mean, let's be honest. You've had someone on your watch who got traumatically injured. I mean, that could be devastating to you as a business owner and as an employer. You also have to deal with the fact that, hey, you're one worker down. So it's really going to compromise your ability to get a job done on time. That, of course, is going to affect your profit, the money that you're going to make from that job. You also have to look at the rest of your employees. Now you've got a crew who's got to try to work to make up for that one worker that's down. So they're going to probably overworked. They're going to be exposed to maybe getting hurt themselves. And they're going to be stressed out trying to get that job done quickly to make up for someone being gone.
There's a lot of excuses, shall we say, for not using fall protection or not using it appropriately. Oh, it'll create a trip hazard. Oh, it's a greater hazard. It slows me down. Well, all of those will be vastly changed if one fall injury, or God forbid a fatality occurs, production halts. It's a lot more expensive to take care of an injured person, or sadly a fatality, than it is to purchase the appropriate piece of fall protection equipment.
As an employer and as a business owner, it's going to affect your rates. And you're going to find yourself paying more money in workers' compensation insurance, which is it's going to affect your bottom line. It's even going to affect your ability to go bid for jobs, because there are certain businesses that you're going to go and work for that are going to look at the accidents you've had, the claims you've suffered, maybe even OSHA citations that you've had or complaints. It's really going to affect your ability to get quality work.
Make the decision that your company and the assets that you control, to include your person and your family and those around you, are protected by developing a program that includes your people without regard to the price, because the loss of you personally or the loss of an employee within your company is not recoverable. You don't write a check and make that go away. It's with you forever.
In 2017, there were 5,780 resolved claims in Oregon that were due to slips, trips, and falls. The average cost for these claims was $23,570. Below are a few categories of accepted disabling workers' compensation claims from Oregon in 2018 due to falls to a lower level. 405 from ladders, 44 from roofs, 38 from scaffold, 128 downstairs. In 2018, fall protection was the most commonly cited violation for the Oregon construction industry. Total number of violations, 443. Total initial penalties, $902,990.
I think that when you talk about fall protection and you talk about what things perhaps may be overlooked, the first one is recognition of hazard. If you don't have a hazard, you don't need fall protection.
There are many different industries that are affected by fall protection, from construction to oil and gas, pulp and paper, lumber, general industry, people who are doing some tasks that they may not even think about their need for fall protection in general industry, people in a machine shop where the majority of the workers are going to be working with their feet on the ground. Some of those machines are getting much taller, much larger, and they have to have maintenance done on top of the unit itself, where it's going to be over 4 feet. And in general industry, at that point, they would be required to protect their workers from a fall at 4 feet or higher. Trigger heights are a great question, and they're something that is sometimes very confusing and some people don't know what industry that they're falling into or what their trigger heights are. Generally, we look at 2 different trigger heights. We look at the general industry at a trigger height of 4 feet and above, and we look at the construction industry at a trigger height of 6 feet and above. But we also have the trigger height of any time there's a hazard below us, whether we're at 4 feet or 6 feet or 3 feet. If there's a hazard below us that we could fall into or fall on, then we need to keep those workers protected. And it's really best for everybody to revert back to whoever the controlling employer is, whoever is setting up that safety program, and see what is the trigger height that is being used for that business, that company, or that activity by that employer. Because as we know, when you're working at heights, gravity is there. It never takes a break. It is always working on us. If we do something incorrectly, we are always going to be under the effects of gravity pulling us down. The only thing that's going to stop us from having a bad day is if we are provided solutions that keep us either from falling, or if we do fall, from hitting the ground or a lower level.
We were up on a re-roof. We were doing a re-roof of about a 100-year-old barn, so we knew that some of the structure was a little bit dicey, a little bit rotten up top. And all of a sudden I hear a crack. And I look over and I can't see my partner anymore. And what he's done is he's stepped through some rotten boards and he's now dangling inside the barn. It was probably about a 32 to 34 foot fall, and I'm assuming that he wouldn't have made it from that. And without that fall protection, he wouldn't have survived.
The amount of stories that I get to hear every day of workers that have used fall protection and it has saved their lives is too numerous to account for. Injury and fatality statistics are something that are reportable. Very rarely is it reported that, yes, we did this the right way. However, I get to have personal stories with a lot of individuals that have used either fall protection or sometimes our fall protection, and that it has literally saved their lives. It was the one thing that caught them because they slipped, they tripped, even though they'd been walking for 10 years, 15 years, 20 years.
Throughout my years, I've had a few people fall into their harnesses where they were well above 20 feet, and then the harness caught them. We were able to retrieve them, get them off, and then redo the fall protection system, evaluate what we're doing, why they fell, and they were able to keep working without an injury.
I am aware of multiple examples where fall protection has saved someone's life. Most recently, a coworker of mine was running a project here in Portland where we had an iron worker fall into his fall arrest system and did save his life.
During my time as a specialist, what really struck me are the 20 to 25 phone calls that I would get every year from my customer base out of the blue, unsolicited calls saying, hey, we had a fall on the job site today. Everything worked perfectly. Nobody got hurt, everybody walked away, the employee's back to work, everything's good. Really appreciate what you guys have done to bring awareness about the hazards and help us keep our programs moving correctly in the right direction.
So we know it works. We know that if you develop a program, you have the right equipment, you have the right engineering, and you have the processes necessary to protect people, and the willingness of the individuals on job sites to use the equipment provided, we have success. And I think you can easily look at incidents and accidents, not only in Oregon, but across the board in the continental United States. This has been a very successful program.
When it comes to fall protection, you need to know which standards apply to your workplace. Employers have the responsibility to provide a safe workplace and to communicate safety requirements to their employees. The purpose of this video is to help you become familiar with widely used OSHA standards that relate to fall protection. OSHA standards are rules that describe the methods that employers must use to protect their employees from hazards. Please keep in mind that federal standards are adopted nationwide and some states create their own additional requirements. This training is based on Oregon OSHA standards, which you can get from our website, osha.oregon.gov. Once the page loads, Click on A to Z Topics in the top left corner. The go-to standard for construction is Division 3, Subdivision M, titled Fall Protection. This 52-page document is a critical building block for many companies' safety programs because it outlines the specifics for most fall protection systems. For requirements regarding scaffolds, scissor lifts, boom lifts, and aerial platforms, please refer to Division 3, Subdivision L. For requirements regarding steel erection, please refer to Division 3, Subdivision R. General industry fall protection is covered in Division 2, Subdivision D, titled Walking Working Surfaces. The term general industry refers to all industries not engaged in agriculture, construction, maritime, and forestry activities. Scaffolding requirements in general industry are referenced from the same one that construction uses, Division 3, Subdivision L. Personal fall protection equipment is covered in Division 2, Subdivision I, Personal Protective Equipment. It will be of great value to you and your company to have a good knowledge of OSHA standards that relate to your industry and how to apply them. Before you begin a job or a task, you need to conduct a risk assessment. Risk assessment is the process of evaluating potential safety and health hazards that workers may be exposed to during a job or task. Risk assessment in regards to fall protection requires you to identify all fall hazards and take the proper precautionary measures before work begins. Let's start by defining what a fall hazard is. A fall hazard is anything that can lead to a loss of balance or body support and results in a fall. Common examples of fall hazards include unprotected sides and edges, floor holes, and wall openings. So you'll want to start with identifying any task where workers may be exposed to fall hazards, which involves reviewing worksite plans and assessing the work area as a whole. It's important that you start from the ground up, evaluating each phase of the project. Begin by making sure that all surfaces have the strength to hold workers and their equipment, and all jobs or tasks that expose workers to falls are identified. There's a variety of fall hazards, and there are different trigger heights dependent on the work being done. A trigger height is the minimum height at which you're required to take action to protect workers from fall hazards. Oregon OSHA enforces a number of different trigger heights. It's important that you identify the trigger heights that apply to your industry and the work being done, and then plan fall protection accordingly. Some of the more common trigger heights include working above dangerous equipment, aerial lifts, general industry, construction, scaffolding, motor vehicle surfaces, general steel erection, and fixed ladders. Oregon OSHA has many helpful resources to assist you with identifying the trigger height that applies to your job. Just click on the link below. Evaluating fall hazards isn't something you need to do on your own. It's smart to involve others in the process, such as workers who may be exposed to fall hazards and their supervisors. Your workers' compensation insurance carrier will also help you evaluate fall hazards by simply requesting a consultation. The bottom line is this: before you start a project, think about the fall hazards workers may encounter and take action to keep them safe. A fundamental aspect of using fall protection is understanding competent and qualified people. In this video, we'll explain what both these terms mean and how they apply to your fall protection strategies. Let's start with the OSHA definition. Competent person means one who is capable of identifying existing and predictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to the employees, and who has authorization to take prompt corrective measures to eliminate them.
It's that authority to take prompt corrective action that really makes somebody competent or makes them so that they're not so competent. Unless they have that authority to correct the hazard that they found, they can't be competent. The only person who can deem somebody competent is the employer. It's not up to a third-party training company or anybody else to say this person is definitely competent, even if they come through it through training. And there are a lot of different training classes that are out there. 3M offers a 2-day competent person class where they learn to identify hazards, inspect the equipment, take a test, and then we do it for a knowledge check at the end to make sure that they've retained what they've heard. Even after doing all that and being issued a card, that doesn't mean that they are competent unless they go back to their employer and the employer accepts that and recognizes them as competent. There are a lot of people out there who are very competent who have never been to any kind of a class because they know how to identify those hazards. They know what is right and what's wrong, and the employer has given them that authority to correct anything that they found that's not correct.
Qualified means one who, by possession of a recognized degree, certificate, or professional standing, or who by extensive knowledge, training, and experience has successfully demonstrated their ability to solve or resolve problems relating to the subject matter, the work, or the project.
Qualified person in fall protection means a lot of different things. It could mean an engineer, a structural engineer or a mechanical engineer who has been able to self-engineer horizontal lifelines or is able to look at the loads going into a concrete column or a wall or a form and say that yes, the way that this is situated, it can handle whatever the loads are that are going to be put into this, along with whatever else it had to support prior to that. Horizontal lifelines are probably where we see the qualified person in fall protection being referenced the most, because all horizontal lifelines have to be designed, engineered, and used under the supervision of a qualified person. And the manufacturers that manufacture even temporary horizontal lifelines use that same verbiage, that whoever is setting those up needs to be a qualified person. That doesn't mean they have to be an engineer. We don't need to have a structural engineer out there moving horizontal lifelines every hour across a deck. It means we need to have people who understand how to use that, how to set it up, how to make sure that they have the right clearance, how to make sure that the hazards on the workplace haven't changed in a way that as I move it from one place to another, I no longer am protected the way I was previously. And they also have to know when their qualifications run out, when they need to find somebody who is qualified to a higher level than they are. Are they questioning what the structure of a rebar cage is, or a column, or a wall, or a beam that they're going to connect to, and when do they need to stop, reevaluate, and maybe get at their qualified structural person in there to take a look at those situations.
If you would like to learn more about competent and qualified people in relation to fall protection, feel free to download our fact sheet below. Before we discuss fall protection systems, let's look at some component definitions. We'll begin with the ABCs of active fall protection. That's anchors, body support, and connecting devices. We'll also look at deceleration devices, so it's more like the ABCDs of fall protection. Our first term is anchors. Anchors are a secure point of attachment for equipment such as lifelines, lanyards, and deceleration devices. Anchors can be permanent or temporary, and how you select them will often depend on the type of job or task you'll be doing. Next up is body support. Body support options can be divided into two categories. These are body harnesses and body belts, both of which have different applications. A body harness is a piece of equipment that is comprised of straps that secure you in a way that will distribute force caused by a fall across your body and allows you to connect to other components in your fall protection system. A body belt is a strap that secures around your waist and is used to attach to other components such as a lanyard. Its use is more limited than a body harness and is only allowed in a positioning system or travel restraint systems. Next up are connecting devices. A connecting device is used to connect parts of a personal fall protection system together. Common examples include lanyards, snap hooks, D-rings, and carabiners. Let's define these terms. A lanyard is used to connect to a body belt, body harness, deceleration device, lifeline, or anchorage. It is comprised of a flexible line of rope, wire rope, or strap that usually has other connectors at each end. Snap hooks have a hook-shaped body, normally with a closed gate or something similar that can be opened to hook to an object. After it is released, the snap hook gate will automatically close to clutch the object. A carabiner, on the other hand, has a trapezoid or oval-shaped body with a closed gate, or something similar that can be opened to attach to another object. Just like the snap hook, it has to automatically close to clutch the object. Keep in mind that even though something is auto-locking, it's always good practice to double check. It's important to note that not all carabiners are appropriate for your fall protection system, since they must be auto-locking, require at least 2 separate and consecutive movements to open, and be capable of withstanding 5,000 pounds of force. This means they meet the ANSI Z359 requirements. The final component we will be defining in this video are deceleration devices. A deceleration device is a mechanism that dissipates a substantial amount of force during a fall. Common examples include ripstitch lanyards, also known as shock absorbers or shock packs, self-retracting lifelines, and rope grabs. Let's briefly cover what each of these mean. A rope grab travels along a vertical lifeline connected to anchors. When a fall occurs, the rope grab automatically engages and locks to arrest the fall. SRLs, sometimes called yo-yos, can be described as a drum-wound line that can be slowly extracted or retracted when the drum is under slight tension during normal movement by the employee. If a fall occurs, the device automatically locks and the drum arrests the fall. Shock absorbers deploy when a fall occurs. The stitching rips, which absorbs a substantial amount of force that has been created, softening the blow.
Falling object hazards occur when employees are working above other employees. I knew a lineman who worked on metal towers, and he dropped a nut one day, and this nut was like the size of a softball, and it fell from the top of that tower, and it took the ear off of a man that was working below with him, which means it was within 1/4 of an inch of cracking his skull. So that's what falling object protection is all about.
So there's several ways that an employer can protect their employees from falling object hazards. The first one is eliminate the hazard altogether by not allowing employees to be underneath areas where materials can fall from above. So as long as there's no employees underneath, there is no exposure to a hazard and you don't have to worry about it. But if employees do need to work underneath, then we want to take into consideration things like if you're using a guardrail system above to prevent employees from falling to a lower level, that we have toe boards installed to prevent tools from accidentally being kicked over the edge. Other options would include building some sort of canopy system that employees below, as they enter or leave the building, will walk through a sheltered canopy area. So if anything is dropped or fallen from above, that item will strike the canopy and not the employees walking through essentially a tunnel that is created. Another way is to ensure that everyone who is working above with tools has equipment with some sort of lanyard. So if you're using a wrench or a screwdriver, that there is a lanyard attached to that tool that if you were to inadvertently drop it, that instead of falling all the way to the ground where employees are located below, that the lanyard would allow it to drop, 18 inches or 2 feet, and that's it. The employee who's using it can pick it back up and holster it appropriately.
Once you've identified potential fall hazards, you need to select the appropriate solution. At a basic level, fall protection methods can be grouped into 4 strategies. These are eliminate, prevent, control, and warn. Let's take a minute to explain what these mean. When you discover a situation where workers can be exposed to fall hazards, the first strategy to consider is eliminating the exposure to the hazard. The concept of preventing falls is to restrict the employee's ability to reach the fall hazard. This includes equipment options such as guardrails, hole covers, and fall restraint systems. If the first 2 strategies are not feasible, the next would be to consider controlling the worker's exposure to the fall hazard. Keep in mind, with this strategy, the employee is exposed to a fall. However, we're limiting the impact and stopping the employee before they hit the ground or a lower level. Options in this group include self-retracting lifelines, or SRLs, fall arrest systems, positioning devices, and safety nets. The final strategy is to warn workers when fall hazards are present. This can take various forms, such as warning lines and, in unique instances, safety monitor systems. Over the years, fall protection has evolved and continues to evolve. There are numerous ways to protect your employees from fall hazards. The strategies presented here aren't just things you can do to protect your workers, but a method of evaluating your options. No matter what the situation is, there is always a solution.
In the hierarchy of control method, there's a few different ways that people look at it, but in essence it falls down into this element. We want to go from the least risky as our first choice, and then a little bit of risk, medium risk, higher risk, and highest risk. So the options that usually are used is, first is hazard elimination.
Let's face it, it can be difficult to achieve elimination. It requires thinking outside the box and may not be available in every situation. So when there's fall hazards, the first thing we need to ask ourselves is, can we change the way we work, the location, or possibly the equipment? Here's some examples. Perform construction work on the ground before lifting or tilting components to an elevated position. Use tool extensions whenever possible to allow work to be done from the ground. Sometimes, substituting one piece of equipment for another one that doesn't put workers at risk could eliminate the fall hazard. This may require some extra planning before a job, but could really pay off in the end. When you have decided what types of tasks you need to do to complete a job, shop around for different equipment options and plan procedures that will not only perform the needed tasks, but will also provide the best protection from fall hazards. The next strategy we'll discuss is preventing falls. While this includes several solutions, the goal is to keep workers from reaching the fall hazard. In this video, we'll talk about the basics of guardrails, hole covers, and fall restraint systems. A guardrail system is a barrier set up to prevent people from falling off a side or an edge, and must be able to withstand 200 pounds of force applied in an outward or downward direction to the top rail. Here are the essential elements of a guardrail system: a top rail, mid-rail, supporting posts, and a toe board, also known as a kick plate. The top rail should be 42 inches high, plus or minus 3 inches. Your mid-rail should be installed midway between the top rail and walking working surface. It must be designed to withstand 150 pounds of force in a downward or outward direction. Both the top rail and mid-rail need to be at least 1/4 of an inch in thickness. If you're in a situation where objects such as tools or debris are nearby, you are required to install a toe board to prevent these objects from falling over the edge and hitting workers below. It must be at least 3.5 inches tall, can't be more than 1/4 of an inch above the walking working surface, and must be designed to withstand at least 50 pounds of force in a downward or outward direction. Before setting up your guardrail, please consider how you'll safely allow your workers to access the work area. The use of a gate or detachable chain are common methods to do this while minimizing the exposure to the fall. There are many types of guardrail systems. Some are portable while others are permanent. And not all guardrails look like the example here, as Oregon OSHA standards allow for certain alternative materials and designs. For more information, please reference the appropriate standard for your industry, whether that's Division 3, Subdivision M for construction activities, or Division 2, Subdivision D for general industry activities.
Guardrails can be very effective when used properly in fall protection, allowing us to set up a system that denies access to that edge. When a guardrail is set up, it requires very little training from the person who's using it. If I'm using it, when I walk along and I bump into a properly set up guardrail, as long as I don't crawl over the top of it, I've pretty much done exactly what that guardrail was intended to do. It has stopped me from being able to get over that edge. We see guardrails set up in a lot of different industries. We see them on low slope roofs, on commercial roofs, to keep people protected when they're working around either skylights or around the mechanical utilities that are on top of the roof, or having to do maintenance out near the edge of the roof where they want to protect a worker but they don't want to have them in an active fall arrest system. We see them in general industry as well on things like heat treat ovens in areas where workers may have to get up on top of large pieces of equipment, almost the size of a building inside of a building, and provide fall protection where there may not be any anchor points over the top of them, or they've just realized that a passive system like a guardrail is going to be a better option.
Hole covers are used to prevent falls by covering holes in floors, roofs, and other walking working surfaces. They need to be able to withstand, without failure, twice the weight of the employees, equipment, and material that might cross over. They also need to be color-coded or marked with the word hole or cover, and be secured when installed so that accidental displacement is not possible. Fall restraint is a personal fall protection system that prevents the employee from falling any distance. Its components are a body belt or body harness, an anchorage, connectors, and a lanyard. The lanyard acts as a leash, preventing the worker from reaching the leading edge. Anchors used with fall restraint need to be able to support 3,000 pounds per employee attached. If your anchorage is less than 3,000 pounds, a qualified person needs to design and install the anchor, determine if it has a safety factor of 2, and supervise the work being done.
The benefit of guardrails over control options is that after they are installed correctly, they reduce the amount of human error. Parts include top rail, mid rail, intermediate vertical members. They can also be combined with toe boards that prevent materials from rolling off the walking working surface. Fall restraint systems prevent workers from reaching an unprotected edge, thus prevents a fall from occurring. Parts include lanyard, connectors, body harness, or body belt. The anchorage must support at least 3,000 pounds, or be designed and installed by a qualified person and have a safety factor of at least 2.
Our next strategy is controlling fall hazards. This means that if a worker takes a fall, their fall protection system is designed to slow them down and distribute enough force to prevent injury.
The benefit to using an SRL versus using a lanyard is on a lanyard system, although a fixed length, you have to fall the full length of it before deceleration occurs. Whereas using a retractable, it has the ability to arrest the fall in a very short distance. Class A's are 24 inches or less, Class B's with a maximum of 54 inches. And reality is that if a block or a small block like this being attached to the anchorage and this being attached to the worker, if they begin to fall or begin to accelerate, it's going to stop them in a very short period of time. Class A retractables, generally speaking, are smaller block retractables or little ones also commonly known in the market as a PFL or a personal fall limiter. And the presence here is that on these, we can go block to the anchor, hook to the worker, or because it's a personal fall limiter, it can be worn in a condition where the block goes to the worker and the hook goes to the anchor. It will still arrest in the same configuration, but the idea is that the lightweightness of it allows it to be permanently or temporarily affixed to the worker this way, as opposed to having to find the anchor and then attach to your D-ring in that configuration. When we need longer lengths, longer than 6 or 10 feet, because some of the work environments that we use require a longer lanyard, then we get into medium blocks or large blocks, and there's even 200 footers on the market. But standard, you're going to see somewhere between 20, 25, 30, 35, 50, 75, 60. There's a couple different ranges. Now, as a Class B retractable, although it has the ability to go a little further in a test environment, in most cases, if the anchorage or the block is above your head and you're falling directly below it, it will react very quickly using the fact that the drum will spin, and it is almost the same principle of that of a seatbelt. You move at a normal pace, it will pay out. You come back, it will retract back in, reducing the potential for trip hazards. But the fact that it will arrest your fall in such a short distance only benefits us in many cases. Less forces to the body because we haven't accelerated, and now I need less clearance because of the design features.
Fall Arrest is a personal fall protection system used to control an employee's fall. Its components include an anchorage, body harness, and a connector. The connector needs to include a deceleration device like a shock-absorbing lanyard, which is attached to the D-ring on your harness. If you're planning on using Fall Arrest, it's imperative that you understand how to calculate fall distance and use appropriate anchorage, both of which are covered in other videos.
When we move to Fall Arrest, the systems and the components that you're connected to are doing absolutely nothing for you until after you go off that edge, until after you fall. And once you fall, they should be designed so that they stop you before you can hit a lower level or the ground, and then arrest that fall and bring those forces down to an acceptable level, which is 1,800 pounds by OSHA, or an average of either 900 or 1,350 pounds by ANSI, depending on what product it is. But then we also have to take into effect, were our anchor points strong enough? Fall restraint in Oregon, we need 3,000 pound anchors. In fall arrest, we need 5,000 pound anchors or 2-to-1 safety factors. Do I have the correct anchors? What happens after the fall? Do I have systems set up so that I can rescue the person who's just fallen? Does everybody understand that there might be some swing fall involved and that they're further down than they thought they might be? So there's a lot more that has to be done. There's a lot higher level of training that has to go on with fall arrest than there is with fall restraint.
A positioning system allows an employee to be supported on an elevated vertical surface, like a wall or windowsill, and have both hands free. It needs to be rigged so that an employee cannot fall more than 2 feet and support twice the impact load of an employee's fall, or 3,000 pounds, whichever is greater. A common example of the system would be ironworkers that use positioning systems while tying rebar.
A safety net is a synthetic material that has been put up underneath or around a place where there's a fall hazard, and it's been designed to be a system where workers or objects, sometimes safety nets are for people, and sometimes safety nets are for catching debris that could be falling down onto the people or things. And sometimes safety nets are a combination of personal and debris netting. We see safety nets being used a lot in bridge work. We see them being used in open atriums. On the East Coast, we see safety nets being used a lot. On the West Coast, we don't see safety nets being used quite as much as we do on the East Coast. Netting can be a very effective means of fall protection. A properly set up net in construction on a deck can protect a lot of people at once. A netting system, when properly set up, protects everybody that's around it without them having to do anything else at the same time.
A personal fall arrest system consists of an anchorage, connectors, and a full body harness that work together to stop a fall and to minimize the arresting forces. Other parts include lanyard, deceleration device, lifeline. Positioning device systems support a person who needs to work with both hands-free on surfaces such as walls or windowsills. Also used on formwork and for placing rebar. They provide support and must stop a free fall within 2 feet. Parts include anchorage, connectors, body support. Safety net systems consist of mesh nets and connecting components. Their openings can't be more than 6 inches on a side, center to center. They must not be installed more than 30 feet below working surface. They must be able to withstand a drop test consisting of a 400-pound sandbag, 30 inches in diameter, dropped from the working surface. They must have a minimum horizontal distance to the net's outer edge, which depends on how far below the working surface the net is placed.
In this video, we'll briefly cover 2 options that are only available as fall protection on low-slope roofs. These are warning lines and safety monitor systems. You should think about using these options when there's a situation where you cannot eliminate, prevent, or control a fall hazard on a low-slope roof. The Oregon OSHA definition of a low-slope roof is this: a roof that has a slope less than or equal to a ratio of 2:12, vertical to horizontal. This means there's 2 inches of rise for every 12 inches of roof. First, let's talk about warning lines. Warning lines are a fall protection system that surrounds all sides of the work area, placed at least 6 feet from the edge, and are made up of supporting stanchions and lines such as rope, wires, or chains that are flagged with high visibility material. Next is safety monitor systems. The safety monitor system uses a competent person to warn roofers when they are in danger of falling. Since the safety monitor is responsible for recognizing fall hazards and warning workers about them, they are required to stay on the same walking working surface as the roofers and avoid doing any other work. The safety monitor system is available as a primary fall protection option for roofs that are 50 feet or less in width. There's a lot more that goes into these options than presented here, so if you are a roofer and are thinking about using these options, please take our roofing course, review other materials on our website, osha.oregon.gov, and read the Fall Protection Standard, located in Division 3, Subdivision M.
A warning line system's purpose is to warn roofers that they are near an unprotected edge. They consist of ropes, wires, or chains, and supporting stanchions that mark off the area where work can be done without other types of fall protection. They can only be used for roofing work on roofs that have slopes of 212 or less, vertical to horizontal. Safety monitoring systems for roofing work can be used only to protect employees on roofs that have slopes no greater than 212. They are not permitted on roofs more than 50 feet unless a warning line system is also installed to keep employees from coming too close to an unprotected roof edge.
When it comes to inspecting fall protection equipment, there are a lot of different aspects to it. Ultimately, you should always follow the manufacturer's recommendations or instructions on the frequency and what you're looking for that makes it a pass or a fail. General practice is that at minimum, according to the ANSI standards, which most equipment in today's manufacturing world is made to, is at minimum an annual basis. More frequent inspections for the harsher environment are highly encouraged because the equipment is being used. Concrete guys or people that are working in a high chemical environment, things that will degrade the equipment faster in an environment that's a little more brutal to the equipment than, say, a general industry environment where they wear it occasionally.
Some of the things that come to mind are really making sure that we're getting that annual inspection done by somebody other than the person who's been using that fall protection equipment day in and day out. What we see a lot of times is the worker who's using it and picking it up and putting it on from the time it was brand new to the time that it starts to get old and worn, they're not noticing some of the changes that have occurred with that equipment. They're not noticing how it's starting to get worn here and there. It's getting a little discolored in this place or that place. We need that fresh set of eyes to come in and take a look at it and determine, is this overall starting to lose its integrity? Is the overall condition, while it may not have one specific burn or one specific cut, is the overall condition of this getting to be such that it needs to be taken out of service?
The easiest way to really bring inspections, other than frequency, down to its most simplistic element is if during the inspection the harness has been deployed or the equipment has been used in a fall, no ifs, ands, or buts, it should be immediately removed from service so that nobody can use it. One fall, that's all it's good for. And then of course consult the manufacturer whether or not they have a replacement program. The next would be if the equipment has become aged or has just been in our work environment for such a period of time that it is now either old or no longer viable. Webbing becomes brittle just over time, even if it's cared for in a cool, dry place, avoiding chemical attack and paints and solvents and UV exposure and critters and other things that can degrade the equipment. Most of the equipment that has metal components, that is, metal is steel, even though it has corrosion-resistant finishes on it. So really the easiest way to define inspections is follow the manufacturer's instructions, but what we're looking for is anything that damages, hinders, or suspects its structural integrity or its functionality. If the snap hook doesn't close, the spring won't spring closed, there's signs of rust, not just a little surface rust, but actually corrosion, that now the metal is suspect. Because it's got a little rust on it doesn't mean oh my gosh, it's going to break right now, but it is no longer as strong as it needs to be when we talk about a dynamic load that is going to be applied should a worker actually fall. And there's no reason to ever sit there and go, well, I think I can save somebody's life, is not an acceptable answer. So let's talk about some of the components of a personal fall arrest system. We'll start with the harness. All harnesses are designed so they have some basic elements. They must have shoulder straps, chest strap, a leg or thigh strap, a subpelvic or a pelvic strap, and a waist component. And the waist component is the fact that on a harness, the front becomes the back and the back becomes the front, and it will cross over, as you'll see once we fit the mannequin. So we're going to fit it onto this torso and kind of talk about some of the aspects. So once we open it up, we take the harness off. The easiest way to do it is to throw the harness up over the shoulder blades, just in that kind of manner, as we put it over like that, and then kind of put that in a position where it is in that upper part of the back on our body, and then check the height of the subpelvic strap. Initially, you'll be able to tell whether a harness will or will not fit an individual. There's many different sizes, many different functions, many different elements of a harness, but size is important. The next step is we're going to adjust the leg straps. Now, there are different types of buckles or connectors in harnesses. The most common and most simplistic is what is referred to as a pass-through buckle. And a pass-through buckle is just that it will pass through the one side, and then when we connect it, it will lock into position and we adjust it from there. Another type of connector shown on this harness over here is what is referred to as the quick connect. Quick connects come in a couple different designs, but a quick connect is once we have it fitted, it just quickly connects like that and locks in. You'll find that in chest and leg. You'll find the pass-through in chest and leg. But another version that is very common in the market is what's called the tongue and buckle. And the tongue and buckle, and we'll just display it on here, is nothing more than that of a belt system, but in the legs. And the adjustments are variable, and it's very easy to get it through there and get it connected. And very convenient to fit, especially if we're working in environments where it might be, where we might wear cold weather gear in the morning or wet gear in the morning and towards the day. So it's very easy to adjust these and wear them appropriately. Once we have the D-ring kind of in place, it's still a little loose, we'll undo the leg strap and we'll put it onto the torso. Okay, once we have the pass-through buckle, it is as simple as passing it through like that. And then to tighten, lift up on here and then pull the webbing through that way and tighten it so that it gets tight to the leg. Initially, leave a little bit of flexibility in the legs because we're going to make some other adjustments. And the easiest way to define how we fit a harness is think of it like a piece of shrink tube. You don't want to do it all in one area and then do the other area. You want to do a little on the top, a little on the bottom, a little on the top, and shrink it down to the body style. Okay? And then once we've done one leg and we get it fairly close to being adjusted, you're just going to move to the other leg and wash, rinse, repeat. Now, once we have the legs slightly adjusted, still a little bit of loose, we're going to move to attaching the upper part. At that point, we're going to attach the chest strap and just assure it's connected. The chest strap doesn't have to be so tight that it pulls in. We just need it to lay flat across the chest. The chest strap's job is to assure that the shoulder straps don't come off of the body, and when we fall forward, that it catches the body and puts some of the force into the chest cavity, some into the shoulder cavity, some into the groin and the pelvis, some into the hips. We talked about the crossover or the hip effect, and this is the hip effect, where this shoulder strap comes through and it crosses over here and the front crosses over here. And the idea is so that if we fall, the forces are applied into the structural elements of the human body. The chest strap is also what's called a minor adjustment. You have a lot less adjustability here than you do in a torso strap or in a leg strap. So we want to save this for the last part. Minor adjustment, do the big parts first. When adjusting the torso, depending on the type of connector or adjuster, it will differ how much flexibility or how much adjustability you might have on a harness. And there are different types, ones that are pull up, ones that are pull down, some that have roller buckles, and then other ones that might have what we refer to as a internal adjuster or it's a loop back. So the benefit to a design of this type is that once we adjust it, unlike a version like this that has a lot of extra tail, once we tighten everything up, and even though there's devices there to tuck that tail, on a device such as this, once we have it adjusted, there's no tail because of the design of the tie back or loop through. Adjusting the torso, you're gonna just pull that strap through, and you might have to move the chest strap as the harness moves on our body as we bring up the tension into the harness. So we'll just go through and make some adjustments here. Once we have adjusted both sides, they should be fairly symmetrical. You don't want to see one that's adjusted to here and another one up here, because that will shift how the harness fits on the body. They should be relatively equal, both in the torso as well as in the leg straps. And as you continue to tighten up the torso, remember you're also bringing up the leg straps and the subpelvic strap, which is why initially we leave them a little loose. Once fully fitted, they should be snug to the body and only allow you to allow a flat hand in between your leg and your leg strap or your thigh and your thigh strap so that we can't fit a full fist through there. If somebody was wearing it this loosely, it would be extremely dangerous for them if they actually fell, because all of that force as the body gets picked up like this, as we fall, those leg straps will come up into the groin and create some very significant potential dangerous outcomes. Once we have the top fitted, now it becomes those minor adjustments. As you can see, even though the torso is a specific size, I've made very little adjustment to the chest strap other than adjusting it up a little bit. So there's not a whole lot of adjustment that we want it. And we want it to basically look like the letter H, across the shoulders and across the center. And then make the fine-tune adjustments. If it didn't bring the leg straps up tall enough or high enough into the body, we're just gonna pull through and get those to get nice and tight to the body so that they sit very tight, not restrictive, but secured to the legs. Couple final checks once we have it fitted. If there are extra straps, assure that you tuck them through the buckles that are generally provided on most harnesses so that you can slide it through. And the idea is we don't want them dangling around where they can catch onto equipment or other tools or sharp objects which can pull us or dislodge us. So once you tuck all of those away appropriately, depending on the design of the harness, then we want to do the final checks. Have the worker stretch their arms, bend over, flex, do the things that they would normally do in a work environment to assure that it's not restricting them from doing what they need to do. And then the last check is, again, make sure that the D-ring is in the upper part of the back, centered in the shoulder blades, so that this is our pick point should we fall. So we don't want it low because that will make us go into a supine or Superman position. If we fall and we're suspended, we don't want to go much more than that degree. 30 degrees is the maximum that we want to go. With a heavier weight, it'll actually pull the D-ring off a little bit. It's called harness stretch, which is normal. Then we want to assure that the subpelvic strap, this device right here, is actually underneath the pelvis as much as possible. We don't want to see that strap here or even further here. Its job is, one, to help express that load should we fall and create almost like a little seat. So again, that force, that possible 1,800 pounds, hits us in a place that's a little flatter, bigger footprint, instead of taking it in a sharp object. One thing to remember, especially if you see a worker wearing the harness loosely, is that in a fall, we are accelerating. And OSHA is very specific about the amount of force that is allowed to be applied to the body in a fall arrest scenario. And that number is 1,800 pounds. And whether you actually do the mathematics, you're an engineer, or you're just a human being, 1,800 pounds of force, whether you've felt it before or not, one can assume can have some significant damaging effects to the human body. When it comes to anchorages, there is a significant amount of different types of anchors for different types of solutions, for different types of substrates or structures. There's weld-on versions, nail-down versions, cast-in-place versions. Pretty much any kind of temporary and permanent type of anchorage connection that you can think of probably exists. In selecting the wrong tool or only one anchor to use in many different versions. Yes, it is best to use a tool that is flexible in a lot of different ways, but again, always use the right tool for the job. There are some that are aimed more at a residential or a roofing contractor, and other ones that are more permanent style or other versions. So we'll talk through a couple different selections that are fairly common in the market. In the OSHA requirements, it does mandate that anchorages used in fall arrest be designed with a 2-to-1 safety factor, or 2 times the intended load, or capable of sustaining a 5,000 pound load. Nothing says an anchor has to weigh 5,000 pounds, merely that it be capable of sustaining that load, plus a little extra because we don't want to fall, and then later on it breaks while we're hanging, waiting to be rescued. So the design and features of it is all about engineering and force principles, so anchors don't have to weigh a great deal. They can be even something as easy as a piece of extruded aluminum. All naming aside, whereas some call this a temper anchor, this is an anchor that is designed to go into wood or steel in both a ridge or in field or up to a flat. So anchors like this, depending on the manufacturer and the design of the engineer, can be good for all the way from a 0 and 12 all the way up to a 12-12 pitch, going through the substrate, going into the truss, and in some cases going in field, meaning that instead of being at the ridge, it will come down the eave along the rake or down towards the eave, and then we'll go through here. And you will see there is a lot of holes in there. Most of the time, the anchors will also come with, especially in the residential side, the first set of fasteners, the starter set. It will come with the screws or nails appropriate to install this in the substrate that it is designed for. Again, always consult the manufacturer's instructions on the minimum size, strength of the substrate and either have it evaluated by a competent person, or in some cases, you may need to have a qualified person to verify that the structure is strong enough to withstand the forces. As we've talked about numerous times through this, it is always about choosing the right tool for the job based off of the environment that we work in. As we go through, there are, again, literally hundreds and hundreds of different types of anchors or similar designs that do the same thing for the different substrates. Some as little as 24 gauge steel, some as much as 1 inch. It all depends on the structure and the design and some other factors, again, so that if the worker does fall, we can assure both from the manufacturer side as well as from the safety professional side that our worker gets to experience this fall whenever necessary, and not as our first priority, but that they survive the fall.
Peak anchors are typically used in the roofing industry and are usually left in place after the job is done for future jobs. Truss anchors and spreaders are used before a structure is fully framed. Specifically, a spreader is implemented before trusses are fully sheathed. Engineered clamps are often associated with 4 different anchor types: I-beam clamp, which adjusts to numerous steel beam sizes; trolley beam anchor, which allows workers greater access to greater work areas without the need for a longer lanyard; standing seam metal roof anchor, which clamps to parallel seams of metal roofs; doorway and window opening clamp, which allows for anchoring between building framing or window openings. Strap anchors are associated with 3 different anchor types: the cable anchorage sling, used around structural steel or I-beams. Drop-through anchorage cable, suitable for concrete or steel, has an anchor point that drops through a small hole in an overhead surface. Strap anchor, which is used for sturdy horizontal structures like beams. Keep in mind, sharp or rough edges could lead to strap damage. Concrete anchors are associated with 3 different anchor types. Concrete anchor strap with D-ring, typically used by foundation and formwork employees. The strap is protected with a sleeve or wear pad from abrasion by the concrete. It is looped around the rebar during pouring and is cut flush with the surface when it is no longer needed. Precast hollow core concrete anchor, which allows one worker to tie off and is used for precast hollow concrete tasks. Bolt-on wall anchor, which can be a temporary or permanent anchor point on a vertical concrete wall. The welded anchors consists of welded D-ring anchor, which is a single D-ring anchor point that can be temporary or permanently welded onto vertical structural steel. Weld-on anchor post, which is a permanent anchor point that is welded to an I-beam. Trench box guardrail anchor is used for performing deep excavation. It is designed with an anchor point on a post near the guardrail. Anchors not welded or clamped in place are comprised of mobile fall protection system types, can be quickly moved from location to location, and come in versions that allow for more than one employee to anchor. Rotating retractable anchor mast, which is most often seen used in sloped residential roofs. It allows the worker a large range of motion and helps to elevate the anchor point above the worker. Dead weight anchor, which is commonly used when performing roof work, and you cannot hammer or drill into the surface. It is made of concrete, steel, or other similar heavy materials to provide anchorage. Bolt hole anchor, which is used in horizontal steel bolt holes.
When we talk about fall clearance and how to calculate our fall clearance, being able to calculate that clearance properly is really, really important. Let's start with our lanyards. When we calculate fall clearance for our lanyards, we're always calculating from our anchor point. We're not calculating that from our walking surface. So the first thing we have to do when we calculate our fall clearance is we have to know what is the first thing that we could come in contact with. Is that a lower level? Is it the ground? Is it something that may be stacked on the ground that could be the first thing that we come in contact with? We also have to know what the length of the lanyard is that we're using and what the deceleration distance is on that. When we calculate fall clearance using a lanyard, we start at our anchor point. We start with what our maximum free fall would be, which is 6 feet, the length of the lanyard. We go into the deceleration distance on that device, which would be 42 inches, 3.5 feet by OSHA standards. Then we have the distance from the worker's back D-ring to their feet, which on average is probably about 5 feet. Our body's going to conform into the harness. That back D-ring is going to stretch up about 1 foot, and then about 2 feet of safety clearance, just in case we calculated correctly or things weren't quite where they needed to be, or we have workers of different weight, brings us to a total of 17.5 feet. So using a standard 6-foot lanyard, we could need a total of 17.5 feet from our anchor point to that next level. That's 6 feet of lanyard, 3.5 feet of deceleration, 6 feet of worker and harness stretch, and our safety clearance at the end for a total of 17.5 feet.
In training for rescue, just like with fall protection equipment, it's going to be dependent on both the scenario and the equipment that is selected as appropriate for the scenario. However, one of the elements of rescue training that is a little different than fall protection training is that once you train people in the proper procedures, even if it's a very simplistic methodology, such as a simple ladder, or we're going to use a scissor lift to retrieve the worker, as long as it follows the policies and procedures that we lay out and the planning, and everybody's communicated and understanding. But when you get into some of the more technical elements of rescue, and there are many, is that those rescuers need to be very, very adept at what they're doing and be prepared to make changes to that plan based off of when an event happens or an incident occurs. Although yes, we can predict a lot of it, there are still unpredictable things that may occur. So they might have to modify that plan. So they have to be super knowledgeable, as well as this is not thought process, this needs to become muscle memory. So one of the encouragements for rescuers is that they regularly practice in a safe environment the skills so that when the event occurs, that they're not thinking about what the procedure is. They are absolutely able to react and react safely to retrieve that worker from this at heights, oh my gosh condition. In any rescue scenario, fall arrest scenario where we could potentially have a hanging victim, rescue is essential, not because it's a law, because you have a potential hanging victim. Depending on the standard or study that you look at, the average amount of time a victim has to remain in suspension is around 15 minutes. Of course, using suspension trauma straps or other devices such as that can increase the amount of time that the victim can remain in that condition awaiting the rescue. But if we're not prepared, people are humans and they're going to do what they need to do and they're going to get laser focused. So there's a bunch of different ways. I always use the KISS method, keep it simple. Using a simple ladder, a boom lift or a scissor lift to retrieve the victim, as long as it's the right tool for the job, then that's perfectly acceptable. But at times we have to get a little more technical. So in this next demonstration, we're going to take our victim and we're going to start down here on the ground. We're going to climb up into the air, remain protected. We're going to get the rescue equipment remotely attached to them, lift them up enough so that we can disengage them from their anchorage and lower them down to the ground to safety, because most of the time going down is where your rescue or your medical professionals will be. But there are times that going up is a necessity. So we have to look at the scenario to assure that we have the right tool for the job, same as any fall protection equipment. All right, once the victim has fallen, at some point somebody's going to scream, somebody's going to make the call that we have a victim. And then of course the rescuer should remain calm, cool and collected, and always be protected. The rescuer's #1 priority is still the rescuer at all times. So we're going to get ourselves up there and we're always going to talk to the victim and make sure the victim's okay, and then we're going to direct the environment. So we're going to tell somebody to call 911, and then we're going to make sure that people are on point. So once we get climbed up here, we'll get protected and we'll talk to the victim. All right, victim, how you doing? Don't worry about it. Looks like you're having a pretty bad day. Let me get connected and safe up here. We're going to get you down somewhere pretty darn quick. So every rescue piece of equipment that uses mechanical advantage must have a minimum of a 3-to-1 mechanical advantage. So that's a little further than I want to be for that swing fall. Let me get connected to here. So as our victim's dangling there, We're just gonna continue to talk to him, make sure that he's okay. Then I'm gonna open up the bag. I'm gonna reach back in, make sure everything's secure. Come out here, grab it, take my sling or whatever anchorage that I need to be necessary to get this attached, get it functional, get it over there, get it close to him, get it attached to me. And then we're gonna start what they call measuring rope. So we're just gonna measure out the rope down to our victim to make sure that we can get it attached. This type of rescue is so that the rescuer can remain in a safer environment and remain up here instead of rappelling down and attaching to the victim. There's numerous versions of this bad boy, or this type of system, and they're all pretty good. They're all effective, but what makes it most effective, and will always make it most effective, is having very well trained and well practiced rescuers. The whole goal is to have those rescuers ready to go and hopefully never use it. If we're doing our fall protection well, we're going to be prepared for all kinds of scenarios. Now once I've measured out the rope, grab my remote pole like this, get it pulled through. Then we're just going to bring the rope up here and get it connected. Again, this is a system. There's a lot of different systems available. But you can see where if you're not practiced, you're not aware of what's going on, or you get in a rush where this can go badly. Because if I drop any of this stuff and I can't retrieve it, my rescue capabilities have just significantly changed. So this little device is just a remote device that is designed to attach to the rope so that I can remotely attach it to my worker's D-ring, get that attached, get it popped up here, get my pole out of the way. Then we're going to start pulling slack out of this thing. We're going to raise him up just enough so we can get him disconnected from his lanyard, because you don't want to just cut it. And we're just going to bring him up a bit. Just enough to get some slack in his anchorage or his lanyard. Then we're going to tell him rope down so I don't hit him with the rope. Attach it like this. And then we are just going to slowly, using rope control and the brake, rappel him down to the ground. And then we're going to have somebody on the ground receive him to make sure that he doesn't just try to run away. But once he's down on the ground, now he's no longer hanging in suspension, no longer waiting for that 15-minute, that restricted blood flow. And he's back down on the ground, and we're safe. In some rescue scenarios, it doesn't have to be highly technical, it just has to be highly effective. So with using a rescue ladder like this that we're going to show, you're going to see where something very simplistic can be effective. So we have our victim Dan down there, and as he's waiting for his rescue to occur, he's going to use his trauma straps, so that way he's not hanging in suspension for any prolonged amount of time, relieving that tourniquet on the femoral artery. Once he gets established, we'll actually deploy the ladder and show what's going on. Dan, you all set? How you doing down there, man? You ready to get out of that position? Yes, all right. So a rescue ladder such as this, it's a pretty simple device. There's instructions right on it, and one of them is open the bag. And of course, then it says reach into the bag and get out your equipment. So at this point, in rescue, we want to look for an anchor that's at least 3,000 pounds strong or 5 times the weight of the worker. In some cases, if you can attach to the same anchor that's just fallen off of, that is perfectly acceptable as well, as long as it's in good condition. So at first, I'm just going to connect the ladder like this, and then I'm going to drop the ladder down. And I'm going to, of course, let my victim know that it's coming. So what you're going to see, Dan, is I'm going to drop this orange bag by you, and I'm going to try not to hit you with it, all right? But you're going to see the ladder come down. To your right, to your right. Okay. As the ladder deploys out like that, Dan can easily reach over and grab it, and then he can just stand up in the ladder. Even if he was incapable of climbing at this point because he was freaked out or anything like that, don't climb up just yet, my friend. He is at least no longer hanging in suspension. He's standing on something, because it ain't so easy to climb these. But each one of the rungs is reinforced and he can easily do this. But this system actually has one other benefit, and it's called a belay system. So we're going to drop the belay down to Dan, and we're going to ask Dan to attach the belay system, or this device, which is nothing more than a carabiner, attached to a rope that's attached to the rescue ladder, and ask Dan to affix this to him. Hey Dan, can you reach that? Can you get that sucker attached? Wait, it'll come back to you. All right, go ahead and attach that to your D-ring, man. And the idea here is that as he tries to climb up, whether he's coming all the way up or we're just climbing him up enough to get him disconnected from his anchorage, we don't want him to have another fall, because climbing a ladder can be a challenging thing after you've just been a fall victim. So all we're going to do is pull the slack out of here. Now, this is a one-to-one mechanical. I can't lift Dan. However, as Dan climbs, go ahead and ascend a rung there, Dan, and as he climbs up, all I'm doing is continuing to pull slack, because if he accidentally loses his grip or his balance in any way, or leans back too far, go ahead and Dan, go ahead and let your feet go for a second. Dan doesn't have another fall. And Dan, how many rungs have you climbed now? 2. 2 rungs is enough to create enough slack in his system so I can get him disconnected, and then I can drop it and I can lower it. Dan, to your left. To your left. We drop that sucker down. Now, Dan, do you want to continue to climb up or do you want to climb down? Okay, can you get your feet back on the rungs?
Yes, sir.
Beautiful. All right. Give me a little slack. Step up. There you go. A little bit more. Beautiful. Go ahead and climb down, buddy. Go ahead and climb down. And as he continues to climb down, all I'm going to do is this. And if he pulls too hard, it'll pull out of my finger and he'll be arrested just like that. So he pulled it out of my finger because he went too fast. Go ahead and step up, Dan. Let me get a little slack from you. Beautiful. You can climb back down now, man. And then he can climb back down and he touches the ground. Give him a little slack. And again, now our victim, in a very fast, effective, and efficient manner, is rescued from his hanging position. With the necessity of inspecting equipment, if a fall occurs, all the equipment, the anchor, the body harness, the connecting device, shall be immediately removed from service. It is highly recommended that if you have a successful fall, that you contact the manufacturer of the equipment being used, because many have policies that they will replace fall-used equipment 100% free of charge, only with a little bit of paperwork and understanding of how it was used.
For instructional purposes only, I'm using a harness that's designed for training. And it's important, if you are running a fall protection program, that you do have a training kit put together and you make people familiar with the requirements for inspection. We'll start with the full body harness. We want to look at the D-ring, make sure it's round, feel it to make sure there's no nicks in it, check it to make sure there's no worn spots here. This is an actual reproduction of a harness that came out of the initial wind towers in Oregon, because when those towers were formed, the weldment to the inside had little sticky outy pokey ennies. And the fellows that were working in there would lean back on the tower and it would puncture their bodies and they would bleed. That's an accident. So they put apprentices, I'm told, in the towers with grinders behind them to knock off those sharp rods of metal, and occasionally they would come in contact with the D-ring. Never inspected. Do you have the same strength in a D-ring that's new and used and perfect as opposed to one that has been worked on? You want to check inside where the D-ring goes through to make sure that there's a protector between the metal and the fabric. In this case, the manufacturer has used a plastic tube that's originally round and rotates. Here you'll notice that there is an overlap because it's had an impact, and when it impacts, that plastic collapses and it stays in that manner to warn you that the harness has been used before. And understand all of this equipment is designed for a single time use and then it's retired. Great place to accomplish your training. I spoke about marking the harness training only, but I also want to tell you that we don't write on the equipment and we don't brand it. I've actually seen fellows use a wood burning tool and brand into the equipment. The reason is these chemical compounds that are in many of your permanent markers have volatile organic chemicals, and they literally melt the fabric that we're working on. So you do want to feel the material by running a hand down it. When you do that, if there is distortion, you want to check and make sure what it is. In this case, we're also examining the fabric. So here I run a finger down, and I've got a small burn here. Well, does it make a difference? Well, it might, because these are all directly involved in protecting the integrity of the fabric. The little stitching you see along here is a wear guard. If you wear the edge through to where the black stitching shows, it's time to get a new unit. You look for completeness and you look for no modifications. Here's an example where somebody trimmed the end off. No telling why, but it's there. And they cut the ends off. That's important to recognize because these tend to slip and move if that break end is removed. You want to make sure that the buckles do work. So when you come to the area where there are buckles, on this side, for example, is a buckle that, if you're not careful, covers up an area. Where you run the webbing through your hands, you'll notice that there is a distortion here. It's no longer straight, it's pulled out around, and that's because this has had an impact, and that's where the impact affected that piece of this material. So it's not straight, it's a little kinky. If you get further down on the harness, you'll find another burn mark. Heat's out there. We want to be very careful that we don't harm the equipment. When we look at the buckles, we want to compare light components. It doesn't take a person to recognize that here there's a keeper spring, here the keeper spring has been removed. That does happen. It maybe has not been removed, but it's missing. Why is that important? Because that keeps this tight so that it doesn't slip should you have an incident or an accident. Be careful with the bottom of the materials. This is an area that's subject to a lot of abuse, particularly around heat. We weld something, we bricks against it, next thing you know, we've literally welded our harness. Material doesn't function well once it's welded on or gets heat. It melts, it gets brittle, and that's a real problem. You want to look at your stitching. So when you look at your stitching, make sure that you turn it over and compare. Obviously complete, obviously worn out. You need those straps to stay in the same place if in fact you do fall. Check and make sure that the buckles that these run through are round. So you'll notice that this buckle and its mate have that same type of protector between fabric and metal designed to roll. So a roller buckle, once impacted, the metal will come out of round and it'll simply overlap itself. You'll also change the spindle, but it's easier to look at that part than it is this part to determine what's wrong. Down on this end, we pay particular attention to the groin straps. We get to one here that's got a dip or a cup in it. That's where the spindle was when this unit was dropped, and it's out around and pulled free. In an actual full fall, these will tear. They tear down the lateral equipment here, and they do provide a little shock absorbency. But they also are intended to break at the ends. And if you cut the break off, it's important that you remember to grab a handful so they don't fall off in your hand. But if you find these things, don't throw the equipment away. Turn it in, get new, or somebody else's good used equipment, and use something like this for training. It's invaluable in what you do. Let's talk a moment about things we don't use. We don't use the bolts, and it's very obvious that something is wrong when you examine the material that's here, that this bolt may be rated, but it's rated only for a direct pull in line with the thread. You get this bolt 90 degrees and you pull it, it's worth about a third of what the unit is worth. These actually come off of a major site here in Oregon that were installed by somebody who knew they needed anchors but didn't understand the application of the bolt. When we look at the snap hooks, they need to be labeled. This one has no label and it's available in any dime store. You'll frequently find these connecting the chains on a trailer with somebody that doesn't value his trailer. A little bit of impact, these go away in a hurry. So you want things that belong. When we look at the snap hooks, a mountaineering type snap hook, very lightweight, nothing wrong with it being aluminum, but it also needs to function. So the spring clip doesn't work, it goes back, it takes a push and then some force to get it to turn. Doesn't belong in the program, and yet they show up all the time. They're exclusive and everybody wants to be a mountain climber, and the colors are predictable. Check your carabiners, need to open and close. Read what's on them. Make sure that you understand what's being talked about. It's talking right here about kilonewtons, and it takes 22.2 kilonewtons to be 5,000 pounds. Legitimate carabiner, it requires two separate actions. You look for a fall protection program, something that opens and closes automatically, not something you have to screw shut. But you check them to make sure they close. You read the labels and make sure they're rated. Legitimate ones will tell you they're rated to ANSI Z359, and they will give you the strength requirements stamped right on the component. Snap hooks, we want to make sure that they're rated, so we look at a snap hook, we see the information that's presented on it. What we want to make absolutely certain is that they are legitimate. Legitimate manufacturers will brand the hook where it came from. It'll tell you that it's a forged hook and it's worth 5,000 pounds. It will open and close automatically, and it's engineered for what's intended. It's interesting. Now here is a rebar hook on the other end, a legitimate chain from somewhere, and I want to ask the question, how do you think that connection right there is rated? Chances are it's not, but chances are it's convenient, and the person with the hook utilized older hooks, piece of roller chain, and something he bought at the hardware store. Please, if you engineer your own equipment, take out your own insurance policies. Bigger is not necessarily better. So here's an example of a large snap hook, opens and closes, but the spring itself is broken. So defective components that create an accident are easy to inspect following the accident, so simply use them. Components have to function. Here's a snap hook that was part of an actual accident, and if you look at this snap hook down this parallel, you'll see here the impact that somebody hit it, so that working with the D-ring, all he had to do was hook it up without manipulating anything. No closure. Recognize too that easy on, easy off. You gotta have that closing gate to make that a legitimate component. Legitimate components, 5,000 pound snap hook. When you look at this one right here, down here, it tells you this end is worth 1,800 pounds. But it is not fall protection equipment. It's an industrial fastener that somebody has sewed in to make a lanyard extension. These guys are probably the easiest to inspect. When you look at one of these, you make sure that the stitching along the outsides is there. You check the snap hooks to make sure they're legitimate, lock and close. And if in fact they don't have a label or they are extended, and it's easy to tell the extension because when it comes out, there will be a wad of material that'll look like it's shredded, and it actually is. And that's where the shock absorbency comes into a shock absorbing lanyard. I was involved as a witness in a lawsuit where a guy fell out of a man basket. He was wearing a harness, and he said that, in fact, the harness failed. So he got injured, showed up in the courtroom with his equipment. So in the course of this testimony, he identified the harness. He identified that he knew how to inspect it. And then I asked, through the appropriate channels, to have him put the harness on. And he stood there in the courtroom and put the harness on his person upside down. The question that our side asked, who trained you?
The importance of training. First, if we look at the OSHA rules, OSHA specifically says It is required that we properly train the employees. Fantastic. Better, it is foolish to put our workers at risk without the proper training. It is paramount, because there's no way that you can actually just hand somebody the book and say, hey, read this, and you know exactly the proper way to use it. Again, back to the whole training aspect, is people learn in different ways. One of the best learning tools, fingertips, or the touch and feel.
Training is a key component when using fall protection systems, because even something as simple as a guardrail, if you have a guardrail system and you don't train your employee on what its purpose is to protect you from a fall hazard that is on the opposite side of the guardrail. We've seen situations where employees use guardrails as a ladder to get a little bit higher. They need to change that light bulb that's in the corner, and there's a guardrail right there. So they stand up on the guardrail and now have exposed themselves to a fall hazard.
Any worker that can be potentially exposed to a fall hazard shall be trained so that they know what the hazards are and know the proper policies and procedures. If they've incorporated a personal fall arrest system, they shall be trained in the proper use, care, inspection of either the horizontal lifeline, the anchorages, the harness, the connecting device with lanyard or retractable or other.
Training is really critical for portable ladders, for rope descent systems, rope access systems, travel restraint systems, personal fall arrest systems, because each one of those systems have multiple pieces of equipment that must be assembled in the correct order, that have incompatibilities, certain ways that they can or cannot be hooked up. They also require a user interface between an employee and that equipment to make sure that it is put on properly, adjusted properly, maintained properly. So without training, an employer is just assuming that the employee knows what to do with it and how to use it, and that's a very dangerous assumption.
We need to train workers on how to figure and calculate their fall clearances and their fall distances correctly, how to look at the devices that they're being provided and come up with what that needed fall clearance is, and also train them on how they need to anchor and where their anchors need to be so that they're staying adequately protected. They need to be trained on all the different areas where they are going and working at heights, on what the approved anchor points are in those areas. They need to be trained on the difference between fall arrest and fall restraint. We need to train workers to be more competent in thinking, can I bring up an idea of guardrails here? Can I deny access in this situation instead of having to put myself in that fall arrest? We need to look at the inspection of the equipment and making sure the equipment is properly inspected. There's a lot of legacy equipment out there from various manufacturers that may not meet the gate strength requirements. And the people doing the training to the workers have to make sure that they're qualified to do the training. There's a higher level of education needed for the people who are training the workers, or higher level of understanding on how to train and what type of content should be trained on as we're training the workers who are using fall protection equipment.
Let's take a moment to summarize the topics to cover in your fall protection training. So your training must include the nature of fall hazards in the work area and how to recognize them, the correct procedures for using, installing, maintaining, disassembling, and inspecting the fall protection systems being used, the limitations and capabilities of the equipment being used, manufacturer's instructions and the importance of following them, the correct procedures for the handling and storage of equipment and materials, and finally, the employee's role in the employer's fall protection work plan. For more information on fall protection training requirements, please reference the Oregon OSHA standard that applies to your work activities, whether that's in general industry, construction, scaffolding, steel erection, agriculture, or other activity. There are separate standards for each of these, and you can view them on our website, osha.oregon.gov.
If you're a new person in charge of training your teams and you're not sure where to start, you haven't built these programs, you don't have the content available to deliver to them, one of the best places to start with is your manufacturers. Look to them for things like Competent Person Train the Trainer classes, where you can come in, you can receive training on the subject matter, and stay for additional adult education training so that you are given a program that you can take back to your company and deliver content that somebody has already developed for you, tests that you can give your employees so that you can make sure that they have understood and are able to articulate back some of the message and information that they have received. Those come in a lot of different levels. There are Competent Person Train the Trainer classes. There are Confined Space Train the Trainer classes. Rescue Train the Trainer classes. There's a lot of ways out there that people can get that information and get better at delivering that information. Look to the manufacturers, look to OSHA, look to the local support groups that are there in your field.
Had I had to do it over again, I would have taken some time to try to make myself as much of an expert on safety as I could coming into that. I think that it's a marketable skill. I think that there's businesses out there that are just looking for people that have that initiative to learn about that, not just the trade itself, but how you remain safe in that. So having that skill, having that knowledge going into it is going to make you a much more valuable employee and a valuable member of that team. And at the same time, it's going to give you a really good idea of how to protect yourself and to keep yourself safe and your fellow workers as well.
In regards to certification of training, the employer must verify that they are compliant by preparing a written certification record. This record needs to have the name or other identity of the employee trained, dates of the training, and the signature of the person who conducted the training or the employer. Once all of this is completed, you need to maintain the latest training certification. In some instances, the employee may have received training from a previous employer. If the current employer is relying on this, the record needs to indicate when the current employer determined the prior training was adequate rather than the date of the actual training. When the employer has a reason to believe that an employee who has already been trained doesn't have the knowledge or skills required, they need to retrain the employee. Examples where retraining is required include changes in the workplace or fall protection systems being used has made the previous training obsolete. It is evident that the employee has not retained the necessary knowledge and skills from the training. Before any employee is exposed to a fall hazard, the employer must provide training for each employee who uses personal fall protection systems or who is required to be retrained as specified by Oregon OSHA.
The question comes up, why go through this? What are the benefits of creating a safety culture? And there are several layers to that answer. The first, most obvious, it's the right thing to do.
And a safety culture is just, it's organic. It's like a relationship. If you don't constantly monitor it and take care of it and stay in tune with it, yeah, it might flow along and seem like everything's okay, and it might be. Everything might be, and self-police is something that we should always encourage of our workforce, because site supervisors, competent persons, presidents of companies, they're not everywhere all the time, but our workers are, and they're responsible for taking care of themselves, as well as us assuring that they know what's up and meeting expectations. So if we're not constantly monitoring it and taking care of it, that culture can shift in a heartbeat.
Safety culture starts from the top down, and really taking pride in it, caring about it, and investing the time and money into proper training and doing enough research on the equipment, the safety tools, so they can properly use it on the job.
Our rules are minimal requirements, and that means this is the least you should do. And when you think about it like that, we're just the first stepping stone. And an employer that successfully builds a safety culture will realize eventually that they have gone so far beyond what the rules require, because it's true, the rules are just the first step.
While there isn't one way to get a safety culture, here are some factors you can consider to get moving in the right direction. Management values. Management should lead by example. This top-down strategy shows employees that safety is very important and valued by the company. Safety communication. Communication should be ongoing with employees. If you see something wrong, say something. Safety practices. Throughout this training, we have gone over several safety practices. You should always understand your company's safety policies and the Oregon OSHA standards as it relates to the tasks you are doing. Safety training. It is crucial that employees using fall protection be trained to at least meet the standards presented by Oregon OSHA. Safety equipment. Use the right equipment for the job or task. Safety inspections. Contact Oregon OSHA Consultation Services with any questions or concerns you might have relating to your work.
Is it difficult to get started using fall protection? And again, if the training is there, the equipment is provided, and rules are set out by the employer that employees will use this equipment when they are in this situation, and it is administered properly, then I would have to say no. It's not any more difficult than any other complex safety program. It's doable, and especially when your life depends on it.
In getting started with fall protection, it's really not difficult at all. Fall protection is available for sale in any town, but also the training is available. There's training online. They're reaching out to OSHA as a great resource as far as asking for general requirements. If you don't understand what the rules are for fall protection, it's all available online. And there's training, there's courses, there are companies that specialize in coming out and training people. So if you've never used fall protection before, it's very easy to get started. You just need to understand what the parameters are that you're going to be using it under.
We get caught up in, oh, I have too much to do and not enough time. We take shortcuts as human beings, not because we're trying to be malicious, but because we are human beings. So to model the right behavior is to not accept, oh, this little gray area. Set the line in the stand as this is the proper behavior and stick to it. The more latitude we give on that side of the fence, the greater that gap goes. There's a saying that we use in some of our trainings, and it's used in other trainings, that comes from an astronaut, a guy named Mike Mullane, as a matter of fact, that he uses the term predictable surprise. If there's an open hole and nobody's protected it, and somebody falls through the hole, when that occurs, everybody acts surprised. But nobody should be surprised because it existed. It was there. We just became blind to it because we got accustomed to it being there. So that predictable surprise is because the gap between what is acceptable practice and what is actually occurring grows and grows and grows and grows, and now between safe and unsafe becomes this blind space. Whereas once somebody identified there was an open hole that was a fall hazard, it should have been corrected right there. No ifs, ands, or buts. Non-negotiable. This is not because it's the OSHA laws. This is because it's human beings.